If you were to be cloned, how many of you would want your clone to look like this? To clone or not to clone? That is the question troubling the minds of many Americans and citizens all over the world. I've done extensive research on this topic, and I can also provide some science-based information that I will be discussing. Imagine how life would become when millions of people start looking alike, acting alike, and thinking alike. There would be no diversity whatsoever in today's society. Cloning may bring advances in artificial organs, cosmetics, and age reduction, but nevertheless, it takes away humans' individuality, uniqueness, and basically that person's right to live his or her own life. Today, I'd like to explain for you the potential dangers of human cloning. The first thing I'd like to discuss is the cloning process to help you have a better understanding of how cloning works. Cloning is a process used to create an exact copy of a mammal by using the complete genetic material of a regular body somatic cell. A somatic cell is any cell other than a sperm or egg cell and contains the complete DNA or genetic blueprint of the animal it came from. Here's a diagram of the process. According to scientists, the most common cloning method, known as somatic cell nuclear transfer, or simply nuclear transfer, requires two kinds of cells. One is a somatic cell, which is collected from the animal that is to be cloned, known as the genetic donor. The other kind of cell required for cloning is an egg cell, which is collected from a female of the same species, known as the egg donor. The scientist then inserts the somatic cell from the genetic donor into the egg and fuses the two with electricity. The scientist stimulates the fused egg, which activates the egg and causes it to divide just as an egg would if it had been fertilized by a sperm cell in a normal human pregnancy, resulting in an embryo. After about a week, an embryo transfer specialist transfers the embryo to a female, sometimes referred to as the surrogate mother, where it continues to develop. After a full-term pregnancy, the female gives birth to an animal that is essentially the identical twin of the genetic donor. So as you can see, there's a lot involved in the cloning and can pose as a potential danger if just one step was wrongly applied. Now that you have an idea of the cloning process, I would like to introduce you to Dolly the Sheep. A scientific breakthrough was achieved when Dolly, the first mammal, was cloned from an adult cell. At the age of 6, Dolly dies from a lung disease, when a fin dorset, such as herself, has a life expectancy of around 11 to 12 years. The greatest danger human cloning poses is a health risk to babies born through the cloning procedure. Research in animals has shown that while cloning is possible, the majority of animals die in early ages of development or shortly after birth. Moreover, a number of cloned animals are born with defects. Some of these defects include lung problems, diabetes, blood vessel complications, and malfunctioning immune systems. Many animal cloners, including Ian Wilmot, the Scottish researcher who successfully cloned the first animal, Dolly the Sheep, in 1997, disapproved of human cloning. Wilmot has said it took 276 failed attempts before Dolly was successfully cloned. Human cloning has never been performed, but one serious possibility is that human clones would also feature birth defects. Today I've talked about the potential dangers of human cloning. Weighing the small benefits of human reproductive cloning against its risks, the verdict seems clear. Cloning for purposes of human reproduction is just simply wrong and should be banned, not only by the United States, but by all nations. Here's something to think about. If human cloning was the past, then both the male and female would no longer need each other to reproduce. In other words, there would be no more excuses such as the female species, I have a headache, I'm on my period, or I'm too tired. As for the male species, it would result in a loss of pride, due to the fact that they would no longer have to compete for the girl.
Can we get the lights again, please? All right. Karina?
Okay. I thought your intro was really effective. You had a funny picture and it grabbed most of our attention. You did state your thesis very clearly, and your transitions were effective. And the only thing is, don't look down so much because it kind of just sounds like you're reading off of the paper, and it just, you could tell like you're completely down into the top of your head. So that's the only thing I would say. Okay.
All right, I like the visualization in your attention device. That was kind of fun. The topic is very clear. You have a very clear statement of what your theme is. It's on the brink of a persuasive speech, and when you get to it at the end of the speech, basically it becomes a persuasive speech. So yeah, I think you crossed that line a little bit. You had a signpost on your first point, but there's no real preview of what the supporting structure is going to be. There's a lot of material. I didn't hear a lot of source citations. I did hear the one quote from Wilmot, and other than that, I assume that you got that information from a variety of places, but none of them were indicated in the presentation. The signposting, like I said, on the first point was pretty good. The transition from the first to the second point was also fairly clear. The visuals are okay. I especially like the one that explained the process. I thought you did a good job just kind of summarizing what the idea was. I thought you did a good job presenting the potential dangers and listing them, and I would agree that there was probably too much reading in the presentation on the delivery scale. All right, thank you.